Michael here. Today's video is about how I plan the cutting up of sheet material. As a cabinet maker, I do quite a bit of this. I would start with something like that, a cutting list. And lay it up on something like that, a cutting plan. Now, although I've been in the trade for, well, this is my 4th decade, you form a lot of habits, a lot of hunches, and so forth, which do make a fairly quick procedure out of the optimisation. But when you have large numbers of parts, and especially if there's a large number of varying sizes of parts, it can be quite daunting nonetheless. Anyway, that led me to assess 5 software packages and ended up buying 2, but I found shortcomings. One was how long they take to process. The second one was they're not actually that efficient on the breakup of the material. And thirdly, probably more importantly, they generate a lot of extra motions because you're turning and resetting, and turning and resetting, and turning and resetting, needlessly, even with fairly large numbers of similar sized parts. I was quite surprised. Anyhow, having a reasonable history in programming, I decided to write my own system. Now, historically, because of my age, I ended up writing in a DOS environment, just because I'm very quick at it. I'll do a demonstration. Now, I'm using Linux Mint Debian, which is arbitrary, it's a Linux distribution, using a virtual DOS environment, a DOS emulator. Now, there are a few quirks with the DOS emulator, so I have to nurse that. Unfortunately, running a 16-bit virtual computer inside a 64-bit machine has its issues. But in any case, it does have an interesting advantage in that I'm able to use any modern printer on the system via the DOS emulator. If it was natively installed on DOS, I couldn't. Anyhow, let's just do a demonstration. Customer called Fred. Kitchen. This is basically just a file name of a list of sheet material. Thickness of edging. Any material ends up with some sort of edge treatment. That's my little code for 1mm thick edging. I can manually type in parts, of course, but I have a quicker way, which I'll demonstrate that now. Let's say, I don't know, let's do a wardrobe unit. DU for drawer unit. Maybe pantry. Change its width. Actually 900. And I might change that to 2. Okay. Kitchen base unit. Three of those. That'll do. Okay, so let's see what that's done. Well, there is our very rapidly created list of parts. The beauty thing about using the canned designs is that all the parts will actually work together to make whatever cabinet design we've chosen. Okay, let's save that. Now I'll run it through the optimizer. I've got these amount to 2 tweaks on the probability engine. That's already been done. You saw that was basically as fast as a screen refresh. Now there is a bit of a quirk on how this operates, so bear with me. To be quite clear, you can see these green areas. They indicate parts that are in fact the same size, and so you can understand how to break up the sheet material, and it can speed processes up at the machine, knowing that you're going to do a set of the same. Okay, so let's go to the next one. Sheet 2, 3, and you can see, well, basically it's done a reasonable job of fitting everything in it can. Now, I've actually done a real job today, and I'll have a demonstration of how one of the sheets gets broken up, and I'll show you that now. Okay, here you can see the actual sheet layout. This is sheet 1. It moves on to sheet 2, and they'll be shown consecutively. This particular cutting plan, most of the parts, because it was a hodgepodge rebuild of existing cabinets which were made in all sorts of random sizes by an on-site carpenter 40 years ago, every cabinet's got a different depth and width and so on, and so there are very few parts that are actually the same size. Normally, if I would make a new kitchen, at least there'd be quite a few common sized parts in them. Anyhow, you can see the parts are getting smaller, and there's more and more groups as they can fit more and more parts on the sheet. And I'm pretty happy with the way the whole thing's optimised. And there you have it. Shortly I'll be showing you a video of me doing a cut up. Now here you can see me grabbing the first sheet. Well, it's actually sheet number 4 in that set. None of the sheets are square when you receive it from the manufacturer, and the cuts are very poorly cut. So the first thing you need to do is trim and square up an edge. That's the first rip cut, discarding a piece. Even with the parts being all varied in size, it may or may not become obvious that these pieces is pretty much one setup for a product, even with oddball sizes. With some of the other systems I've used, I've had to reset just to extract parts. And resetting it, as you can see, is quite wasteful on time. Decided to use the other end of that sheet. As you can see, the pieces that I'm laying on the panel in the foreground, that's showing you the layout as they were laid out on the optimisation. It's quite amusing seeing myself going at 4 times regular speed, but it would be like watching paint dry at normal speed. You'll see the slight differences in all the parts as they get laid down. And of course you can't help set up changes when every part's a different size. But with the way I've laid this on, you can see the tanny coloured panel, you'll be able to see the actual offcut generated from the process. Worth noting that bin in the background, you can see there's a line in the centre. It only holds a very shallow amount of offcut there, and it usually takes me a few times of material cut up before that bin starts filling. It's about 4 months since I last emptied it. And that's that.